this class, I'm going to continue from where we stopped from the derivative of trig functions. So if you haven't watched the previous tutorial I did on trigonometry, perhaps check my channel and you see it's the previous class before this. So you see that. So, so in the previous class, we've derived that derivative of cos x is equals to minus sine x. d dx of sine x is equals to cos x. Also, we worked out that d dx of tan x, derivative of tan x is equals to sec square x, and we have d dx of cos x, which is equals to what? Minus cosec square x. So you have to keep all this at the back of your mind. They are going to come handy while you're differentiating. We'll be making use of them a lot as we go further in this derivative of trig functions. So what's the next thing that we have to do? We haven't derived derivative of sec x and cosec x. So, and that is what we're going to do in this particular tutorial. If y is equal to sec x, so remember from trigonometry, sec x means 1 over cos x. 1 over cos x. Sec x is the same thing as 1 over cos x. So that means it implies y is equals to 1 over cos x. So here now we have a rational, we have fraction. So this is our u and this is our v. So you use quotient rule to differentiate that. Remember quotient rule? Quotient rule says that if y equals to u over v, that means derivative of y equals to v du dx minus u dv dx all over v squared. All over v squared. So in this case, 1 is our u, cos x is our v. So that means you pick cos x, you differentiate u, so you pick u, you differentiate v. So that means this is going to be equals to v, which is cos x. du dx, what's the derivative of 1? 1 is a constant, so the derivative of 1 is equals to 0, minus u, which is 1. dv dx, what's the derivative of cos x? That's minus sine x, right? Minus sine x all over v squared. What's our v? Cos x, that's cos square x. So from what we have there, that means this is equals to cos x multiplied by 0, that's 0. So we have 0 minus 1 times minus sine x, that's minus sine x. So it will be 0 minus sine x. So that's plus all over cos square x. So that means what we have here is equals to sine x over cos square x. So sine x over cos square x. Remember, so this can be written also as 1 over cos x times sine x over cos x. So it's the same thing because we're just multiplying the cos x multiplied by cos x, that's cos square x. So 1 over cos x is equals to what? Sec x. Sec x. Sine x over cos x is what? Tan x. So that means derivative of sec x is equals to what? Sec x tan x. Derivative, if y is equals to sec x, so that means the y dx is equals to sec x tan x. So that's the derivative of sec x. So you add that to the derivative of the trig functions. You have to remember the 6 of them. So sine, cos, tan, sec, cosec. So cosec x, if y is equals to cosec x, y equals to cosec x. Y equals to cosec x. So from trigonometry identity, so from trig, so cosec x is the same thing as 1 over sine x. 1 over sine x. So from what we have here now, so that means this has become fraction. So that means you use quotient rule to differentiate this. 1 is our u, sine x is our v. So using quotient rule, which says that v du dx minus u dv dx, everything all over v squared. So from what we have here now, our v is sine x multiplied by our u is 1. Derivative of constant is what? 0 minus u 1 times the v dx. Derivative of sine x is equals to cos x, right? All over v squared. What's our v? Sine x. That's sine squared x. So from what we have here, so from there, sine x multiplied by 0, that's 0, minus 1 times cos x, that's cos x, all over sine squared x, which is equals to 0 minus cos x as minus cos x, all over sine squared x. So remember, this can also be written as minus cos x minus 1 over sine x minus 1 over sine x multiplied by cos x over sine x. Cos x over sine x. So then remember that 1 over sine x is equal to what? Cosec x. So we have minus cosec x. Cos x over sine x, that's cot x. Cot x. So cot is like the opposite of tan. So tan x is sine x over cos x. Cot x is cos x over sine x. So that means derivative of cosec x is minus cosec x cot x minus cosec x cot x. So the first question we solve is that if y is equals to cosec 2x, the second one is sec 3x squared plus 1. Cosec 2x sec 3x squared plus 1. So from what we have here now, if y is equal to cosec x, cosec 2x. So from what we have here now, this is a function of another function. We have cosec, which is a function. We have 2x, which is the angle of that ratio. So, which is a function of another function. So for you, if you want to differentiate this, you need to apply chain rule. So remember chain rule. Chain rule says that, so if y is equals to f of u, where such that u also is a function of x, then the y dx will be equals to the y du times the u dx. So from what we have here now, if y is equals to f of u, so for us to use chain rule here, we'll say let's u be equals to 2x. So if u is equals to 2x, that implies that y will be equals to cosec u. Cosec u. So then we can differentiate from that. So then the first thing is that we'll find the y du, differentiate y with respect to u, then differentiate u with respect to x, then multiply the two together. So that will be the derivative of the function. So from what we have here now, the y du, since y equals to cosec u, implies the y du will be equals to, what is the derivative of cosec u? Since so from the last derivative that we have, we know that the derivative of cosec x is equals to minus cosec x cot x. So that means derivative of cosec u, that is the y du here, will be equals to minus cosec u cot u. That's the y du. Now the u dx. So u is equals to 2x. So what's the derivative of 2x? That's 2. So now it means the y dx of this function will be, you multiply these two together. So multiply the two together. The y dx will be equals to the y du times the u dx, that is minus cosec u cos u multiplied by the u dx, which is equal to what? 2. But don't forget, but u is equals to what? 2x. So that means we have the y dx to be equals to minus cosec 2x cos 2x multiplied by 2, which will be equals to minus 2 cosec 2x cos 2x minus 2 cosec 2x cos 2x. That is the derivative of that function. So on to the next question. The next question is y is equals to sec 3x squared plus 1. Sec 3x squared plus 1. So this is also a function of another function. Sec is a function of 3x squared plus 1, which is also a function. So we use chain rule, right? So say let u equals to 3x squared plus 1. So if u is equals to 3x squared plus 1, this implies that the y, so y will be equals to sec u. So, and from what we have here, using chain rule, where we know that the y dx, let me change my marker. So using chain rule, where we know that the y dx will be equals to the y du times the u dx. So from what we have here now, our y is equals to sec u implies the y du will be equals to, what's the derivative of sec u? The derivative of sec x is equals to what? So derivative of sec x is equals to sec x tan x, right? So it's equals to sec x tan x. So that means the derivative of sec u will be equals to sec u tan u. So that's y du. Now the u dx. Our u is equals to 3x squared. So differentiate u with respect to x. So 2 multiplied by 3, that's 6. 6x raised to power 2 minus 1. And that will give you 6x. So now the y dx will be equals to 6x multiplied by sec u tan u, right? So you multiply both together. So the y dx will be equals to 6x times sec u tan u. But don't forget that u is equals to 3x squared plus 1. 3x squared plus 1. So implies the y dx will be equals to sec 6x sec 3x squared plus 1 tan 3x squared plus 1. So that is it, 6x sec 3x squared plus 1 tan 3x squared plus 1. So that is the derivative of this function. So this is where we're going to stop in this particular class. I'll see you in the next class.